All right. I'm going to start going over this. So, Natalie, do you want me to just go over the questions that Chelsea got wrong, or do you want me to go through all of them? Because this is her checkpoint. All the questions? Okay, I can go over all of them. That's fine. All right, so this first one says that Joanne is buying a new couch. Maria, I'll look at those later. With a discount of 15%. The original cost of the couch is $610. Which equation represents the final cost X of the couch? Select all that apply. So on this one here, remember anytime you have a percent and a whole number, you want to multiply them. Okay, so if I multiply this by 15%, your percent always needs to go to a decimal first. Okay, so I'd have 610 times 0.15. Now, when I multiply these two numbers, this is going to tell me how, so you can't see my screen. I am sharing. Can you try refreshing this page to see if it works? If that works. Can you see it now? Okay, perfect. All right, so when we multiply these two numbers together, these two will tell us how much discount is taken off of our couch, right? So if our couch is being discounted, would I want to subtract the money that's being taken off or add it? Subtract it, right? Perfect. So I'm going to take the cost of the couch, which was $610, and subtract it from whatever this number is. So I'd have 610 times 0.15, which is how we get this answer here. Okay, so 610 minus 610 times 0.15. And then there's one other one. Now, remember, I think it was in lesson 11, where if we had to decrease, we would take 1 and subtract it by our percent, right? Our percent in this problem is 15. So if I take 1 minus 15% as a decimal, which is at 0.15, I get 0.85. So I could also take this 610 and multiply it by 0.85, because that will tell me also the price of the couch. There's two different ways you can do it. You can do the subtraction method, or you can do this step first and then multiply those two numbers. So there are just two answers, yes. Bye, Maria. I'll look at your project a bit later when we're done here. Do you guys want me to explain why both of these are the same? Like why both of these work? Whoops, I didn't mean to cross it out. Why this and when you multiply it by 0.85 work at the same time? You good? Okay. The next one, number 2. So let's see. Chelsea, you got this one right, but you still want me to go over it, which is fine. So on this problem here, it says that admission tickets to Splashy Falls Water Park sell for $60. This month, the water park is having a buy one, get one 50% off sale. If Max buys 2 tickets together during the sale, what will the total cost be of the 2 tickets? So again, we have a problem where we have a whole number, which is the 60, and a percent, right? So anytime I have a percent and a whole number, what do I always want to do with them? What would I want to do with the 60? Why is this here? With the 60 and the 50%? Not divide them. Close. What's the opposite of division? opposite of division. There you go, multiplication. So I'm going to multiply these two together, but remember your percent needs to go to a decimal. So 50% as a decimal would be 0.5. So I'm going to take 60 times 0.5. Which gives me 30. Okay, so if I am buying, if it's buy one, get one 50% off, that means that if I buy one ticket, I pay full price, and then the second ticket I buy is 50% off. Okay, so what is the price of a normal ticket? So this is the first ticket I'm buying. Is 60. Perfect. So I'm paying $60 for this ticket. Now my second ticket, this is going to be the 50% off one. How much was it when it was 50% off? 30. Perfect. So I'm paying $60 for one and $30 for another, which means if I were to add these two together, I would pay $90 for my two tickets. Perfect. Chelsea, is that what you did to solve this one, or did you think about this one differently? Differently? How did you do it? Or I guess, how did you come up with your answer here? You added, but it was hard to explain. Okay, that's fine. But it's similar. All right. As long as you got the same answer, then that's what's important, right? Alrighty. Number three. Three says that Barbara deposited $300 into a bank account. If the bank pays her simple interest at the rate of 4% per year, how much will she have in her account at the end of 9 months? So with these ones here, we need to use IPERT. Natalie, I know that you're locked out of the course, but did either of you watch my video that I added where I explained what IPERT is? Yeah, so Natalie did. Chelsea, did you by chance get a second to watch it? Perfect. All right. So IPERT. So anytime you have a question and it's giving you these numbers, right? So it's talking about $300 and $300 depositing in a bank, simple interest rates, and a time frame. You're going to use IPERT. Okay. So let's refresh what each of these mean. My I is interest in dollars. P is my principal or the original amount I deposit. So this is the original amount deposited. R is the percentage rate. This needs to be as a decimal. And T is time in years. Okay, this is very important that it's time in years. So let's look at this problem now. How much does Barbara initially deposit into the bank? $300. Perfect. So since $300 is the initial amount, what variable is 300? What variable do I put 300 in for? P. Perfect, because it's the original, right? So here my P is going to be 300. What is my rate? What is my R? 4%, right? But remember, our 4% needs to be changed to a decimal. So what would 4% be as a decimal? 0.04. Perfect. And then the last one is a little bit tricky with this problem. Let's pick green. T. Right. Now, I have a time frame of 9 months, but remember, I need to have this in years. So Chelsea, you're super close, right? If I put 9 over 12, like Natalie has there, double check it in a calculator. Your decimal's just in the wrong spot. So for t, you can put either 9 over 12, or you can change it to a decimal, which if you change it to a decimal, this is 0.75. So super close, Chelsea. Just had the decimal in the wrong spot. There we go. Okay. So now all that we have to do is just multiply all three of these together, and we will get I, our interest. So I'm going to take 300, multiply it by 0.04 and 0.75. This is going to give me my I, which is how much money she earns in interest. 300 times 0.04 times 0.75 gives me $9. Okay, so after 9 months, she earns $9 in interest. Now make sure that you read these questions carefully. This question wants to know how much money will she have in her account at the end of 9 months, right? So she has money that she deposited in her account, and then she also is gaining she's also gaining this $9 over the course of her 9 months. So if she starts with $300 in her account, like Natalie says, we want to add that 9 so that we get the total amount of money that Barbara now has in her account. So 300 plus 9 would give us that $309. So Chelsea, you were super close here. You just forgot the very last step, which is to add in the 300 back. Because the question is not asking us how much money did she earn in interest. We want to know how much total money does she have. So that's her principal and how much she has total with interest. So that should be 309. And then Chelsea, let me know when you're good. Okay. Do you have questions, or does that extra step that make sense? Perfect. All right, number 4. Let's see. So Jason has 65 t-shirts and wants to give away 15% of them to help make room in his closet. And we want to know which equation will help him determine how many shirts to give away. So I'm going to move this over here so I can keep that, because we're probably going to need that later. And I'm going to use this side to write stuff. All right. So if Jason is giving away 15% of his clothes, which equation will help him determine how many shirts to give away? Well, again, remember, anytime you have a whole number and a percent, you always want to multiply them. So 65 times 15%, but don't forget your 15% needs to go to a decimal. So you're going to have 65 times 0.15. And when you multiply these two numbers, it will tell you how many shirts he needs to give away. So 0.15 times 65. All right, number 5. All right, so here's another simple interest one. Oh no, did I do it? I did it. Yeah. All right, so again, we're going to use iPert. Okay. So Michael deposited $500 in the bank, and he pays a interest that's compounded quarterly at the rate of 4% per year. How much money will Michael have in his account at the end of 9 months? All right. Well, again, we're going to use iPert, right? So P, let's see if we can substitute this just straight into our equation. What the heck? I thought I got the pen. All right, so Natalie says 500 is our P. That's our principal. That's correct. Now, remember, for my interest rate, which is 4%, that needs to go to a decimal. So don't forget R needs to go to a decimal, which would be 0.04. And again, they give us this 9 months, but if we remember from the last problem, we could do 9 over 12 or 0.75. So if we multiply all of these, 75. I get $15. So he's going to earn $15 in interest. Okay. And we want to know again how much money will Michael have in his account. So what do we need to do with that 15 to figure out the total amount of money that Michael will have in his account? Add it to the 500. Perfect. So 500 plus 15 will give us a total of 515 total dollars. Wow, what is this problem? Chelsea, you're in that. Are you okay to go to the next one? Okay. All right. Adelaide earned $150 this week mowing lawns. She wants to buy a new pair of jeans that cost $49, a necklace that costs $19.99, and two shirts that cost $7.50 each. She has to pay 7% sales tax on her purchase. Adelaide's mother tells her she must put 10% of her total earnings in her piggy bank savings first. Adelaide tells her mother that she has more than enough money to save 10% and buy all the things she wants at the store. How much money will Adelaide have left after she puts 10% in her piggy bank and buys all the items she wants at the store? Oh, all right. So there's a lot of things going on in this problem. So before Adelaide can buy all the stuff she wants at the store, what does she need to do first? What does her mom say she needs to do first? Um, Chelsea, what do you mean? You accidentally clicked on an answer? But you still want me to go over this one, right? Okay. All right. So, um, like Natalie said, first she has to do the 10% thing, right? Where she needs to take 10% of the money that she earned and put it into her piggy bank. So, how much money did she earn this week? 150. Perfect. So I'm going to take 150 and multiply it by 10%. But remember, 10% needs to go to a decimal, which is going to be 0.1. So I have 150 times 0.1. So if I multiply these two numbers together, how much money is Adelaide putting in her savings account? I guess in her piggy bank. Take 150 and multiply it to 0.1. $15. Perfect. So $15 is what's going into her piggy bank. So how much money would Adelaide have to spend on her clothes? Right? What would I do to figure out how much money she can spend on her clothes? If $15 she has to put into her piggy bank. Subtract them. Perfect. So perfect, Chelsea. So if I do 150 minus 15, I should get 135. So she has $135 to spend on her clothes. Now, let's figure out how much money she's spending on her clothes. Right, so, let's see. She wants to buy a pair of jeans, and her jeans cost $49. She wants to buy a necklace that cost $19.99. And then she wants to buy two shirts that are $7.50 each. So to figure out how much total money she's spending here, what would I want to do with these three numbers? Add them together. Perfect. Let's add up all that she is spending. Let's see. Natalie says it's $83.99. Let's double check. $83.99 is correct. So $83.99. Now don't forget that she is buying all of these items, but she also has to pay a 7% sales tax on her purchase. Okay. So to figure out how much her sales tax is, I need to take the total that she's paying and multiply it by that 7%. But don't forget, 7% needs to go to a decimal first. So I want to multiply this by 0.07. Perfect. And let's see how much she's paying in sales tax. So 83.99 times 0.07. Let's see. So it looks like she's paying $5.88, right? So since we're talking about money, let's round this to the nearest hundredth because we only have two decimals when we're talking about money. So this 9 right here is going to make this 7 bump up. So it's going to be 588. Okay. So she's paying $5.88 in tax, right? So what would I do with this $83.99 and this $588 to figure out how much total she's going to spend on her clothes? Add them together. Perfect. When we add those two together, so $83.99 plus $588, I get $89.87. All right. Now, we're finally at the very last step. I want to know how much money she's going to have left over after she purchases all of her clothes and deposits into her piggy bank. So she has 135 after she deposits in her piggy bank, and she's spending $89.87. So to figure out how much she has left, we'd want to subtract them, like Natalie said. So let's do this 135 minus 89.87. And we get $45.13. So $45.13. That's pretty good. She has a decent amount left over. That's a lot of stuff and one problem. Chelsea, let me know when you are ready to go on to the next one. All right. 7. Let's see. So Fatima wants to add a 20% tip on a $56 restaurant bill. What strategy can she use to find a reasonable estimate for her tip? Now, I think this is interesting because I actually use this one all the time. Did I erase it again? Oh, well, I guess it's just going to have to stay erased. I actually use this all the time when I go out to restaurants. So I think this is interesting because it's like the most applicable percent thing that we've gone over so far. 20%. So whenever you leave like 20% of a tip, that's pretty common whenever you go to a restaurant. Now, to find 10% of any number, all you have to do is take your decimal and move it to the left one time. Okay, so if her bill is $56, if I take this decimal and move it to the left one time, that gives me 10%. So when I move it to the left one time, how much is 10% of $56? $5.60, right? Now, 10% is half of 20, right? Because if I take 10 and multiply it by 2, I get 20. So when I move this decimal over one time, this is my 10% here. So to take this 560 and I'd have to double it to get to 20, I would take this and multiply it by 2, which would give me, what's this, 1120. So you want to do this part. So you want to round 56 to 60, find 10%, then double it. Technically, you don't have to round it to 60, but I guess here they think it might be a bit easier. One of the other things to notice here is that you want to add a 20% tip, right? This is 10%, 10%, and 50%. None of these will leave a 20% tip, which is why we want to pick this first one here. But I do this all the time. Like if I go to Yeah, that's true. We can wait, Natalie, if you want to ask him to unlock the course. Do you want to do that? All right, number 8. Brady scored a total of 320 points last season for his basketball team. This season, he added 2 extra games to his schedule. Brady thinks this will allow him to increase the total number of points he scored by 5%. How many points is Brady expecting to score this season? Okay. Well, how many total points did Brady score last season? 320. Perfect. And how much is he expecting to increase his score by? What percentage? The 5%. Perfect. So I'm going to take 320 and multiply it by 5%. Whoops, not 50. 5%. But remember to change your percent to a decimal always. So I'm going to have 320 multiplied by what number? What is 5% as a decimal? 0.05. Perfect. Don't forget the extra 0. So let's clear all this. 320 times 0.05. So that means he's expecting his score to go up by 16 points. Okay, so he's expecting his score to go up by 16 points. So if I take his old score of 320 and add it to how many more points he's trying to get, which is that 16, I would get 336. So he's expecting to score a total of 336 points. All right, number 9. Braden is buying a new outfit that is 30% off the original price. The original price of the outfit is $58. Which answer best gives you the estimate for the price after the discount? So on here, what would be the first thing that we'd want to do on this problem? So Natalie says 0.3, perfect. So that's our percent as a decimal. What do we want to do with it? Multiply it by 58, perfect. So 58 times 0.3. And when we multiply these two numbers, what number do we get? 58 times 0.3. 17.4, perfect. 17.4. What does that 17.4 tell us in terms of this problem? What does that 17.4 mean? That's the money after the discount. So I think I know what you're saying, but I think it's worded almost, it's not worded exactly how I was thinking, but you're close. So 17.4 is not how much money he pays. So when we find 30, essentially what we're doing here is finding 30% of this 58, right? So 17.4 or $17.40 is how much money is being taken off of his original price. So this 17.4 represents the discount. Okay, so the discount is how much money is being taken off of the original price. To figure out the price he would pay after the discount, we'd want to do 58 minus 17.4. And we get 40.6. So if we were to round this, he would pay around $40. So with these problems, you always have to read it carefully, because if it's asking you how much or how much money is being discounted, that would be this 17.4. And if it's asking you how much is he paying after the discount, you have to remember the second step, which is that subtraction. All right. Next one is number 10. Let's see. It says that an account has a principal of $300 and a simple interest rate of 3.9%. The table shows simple interest earned in the new account balance for 3 years and 5 years. Okay. So our goal is to figure out how much money and interest he earned after 8 years and what the new account balance is. Let's see how much of this I erased. Not so much. Looking pretty good. So we have our, oh, I just erased more. All right, so this is our R and this is T. Okay, so what is our principal? What's the original amount? 300, perfect. I'll do green. So we have I is equal to 300. What would be my rate as a decimal? So my rate as a decimal, if it's 3.9%. 3.9 is my percent. Remember, we have to change it to a decimal. Zero 0.039, perfect. 0.039. And then how many years are we leaving it in our account? Remember, we're looking at the table, this very bottom one, because this is where our blanks are, right? This is what we're trying to figure out. So how many years has it been? 8 years, perfect. All right, so we're gonna multiply this by 8. Let's type all this into our calculator. 300 times 0.039 times 8. So after 8 years, he earns $93.60 in interest, right? Now to figure out the new balance, which would be blank 2, we need to take that $93.60 and add it to how much he originally deposited in his account. So how much did he originally deposit in his account? $300. So I take 300 and add it to 93.60, which would give us 393.60. So for this question here, you want to enter in your answer like this. What I'm putting in red is what you want to put. 93.6, comma, 393.6. So what I have in red here is your final answer. So make sure that you type it in correctly. Give you guys a second to type it in. Do you put a space? You can if you want to. It should count it if you put a space. If it doesn't, let me know and I can go in and give you credit after. But the space should be okay. All right. Next one, it's number 11. Let's see. Terry estimates 30% of 123 is about 60. Which statement describes why this is not a reasonable estimate? Okay. Well, 123 is really close to what whole number? Or I guess if you were to round 123 to an easier number to work with, what do you think is close to it but easier? 120. I agree. Chelsea, do you think that's a good estimate if we were to round 123 to a better number? Perfect. And if she is going from 120 to 60, 120 is about what of 60? Is it about a fourth, a half, a third, What do you think? How would you go from 120 to 60? What number would you divide by? 2. Perfect. So 120 divided by 2 gives me 60. And dividing by 2 is the same as taking a half, right? If I have a whole pizza and I divide it in half or by 2, I would take half of the pizza away. So, um, this isn't really a good estimate because it's saying 30%, right? 30% is not the same as 50%, because it's not working out. That's what she did. She found half of what 120 was to give us 60. But since we want to find out what 30% of 120 would be, we want to look at these two answer choices with the 1/3. The answer should be exactly 1/3 of 120, which is 140. The answer should be close to 120, which is 40. So the reason why we want to pick this answer choice that says the answer should be close to 1/3 of 120, which is 40, is because the original number in our problem is not 120. It's 123, right? So this isn't going to be exactly 40, but it should be close to it because our original number is close to 120. I know this one was a lot of back and forth. I think it's easier to just figure out what the actual number would be instead of trying to figure out all these things. All right, number 12. Maureen borrowed $700 at 14% simple interest for 1 year. If she makes no payments that year, how much interest will she owe at the end of the year? Well, that's bad. Um, that's a not such good situation to be in, Maureen. She'll be starving. Yeah, or she'll like not be able to afford whatever the heck she had to borrow $700 for. All right. So she borrowed $700, right? So is that the original amount of money that she borrowed? Yes, which means 700 would be my principal, right? So I have 700. Her simple interest rate is 14%. So remember, we need to change that to a decimal. So 14% as a decimal would give us what number? 0.14. Perfect. And how long, how many years has she not made her payments? 1 year, right? It says simple interest for 1 year. So I'm going to multiply this by 1. So if we do 700 times 0.4 times 1, it looks like she's going to owe $98 in interest. $8 in interest. Rate. Natalie, are you good? It's okay. You're fine. We're almost done. We have 3 more. All right, Bindi wants to buy pet food with the 20% off coupon. The original price of the bag of food is $39. Which answer gives the best estimate for the price after the discount? Okay, so again, we have a discount of 20% and a whole number. So what would I do with these two numbers here? What would I do with them? Multiply them. So I have 39 times 20%. My percent needs to go to a decimal, right? So I would have 39 times what number? 0.2. There we go. It's okay. You're fine. At least you figured it out before you multiplied it, right? So 39 times 0.2, which means her bag of food is going to be $7.80 off. Remember that this $7.80 here, this is your discount. So this is how much money is going to be taken off of the price of your bag of food. So to figure out how much I'm paying after, like Chelsea said, we need to subtract it. So I have 39 minus 7.8. Which gives us $31.20. So if we were to estimate about how much we would pay after the discount, $32 would be the closest to this $31.20. So $32 would be the closest. All right, two more. Here's another one. So Rebecca is buying groceries and there's a 9% sales tax. Her total before tax is $67, which answer best estimates her total after tax. So here again, we have a whole number and a percent, right? So I'm going to take 67 and multiply it by what? Oops, 67. Multiply it by 0.09. Perfect. Perfect. When we do 67 times 0.09, I get $6.03. So this $6.03 represents the tax. Okay, so that is how much she is going to be charged in tax. Now, this one is a little bit different from the one we did before because the one we just did was dealing with a discount, right? This is dealing with a sales tax. Is sales tax added on or subtracted from your total if it's a sales tax? It's added, right? So I want to do 67 plus that $6.03. Which tells me that she'll pay $73.03, which is closest to around $75. If your total is $67 and you go to the grocery store and they tell you your total is $603, just leave. There's no way ever that your total will ever be $603 if you're paying for $67 worth of groceries. That's ridiculous. Without everything you wanted. I mean, if I went to the grocery store and I had like $100 and I bought like $67 worth of stuff, I wouldn't even be able to pay the $603. That's ridiculous. Something happened. Alrighty, last one. Bonnie borrowed $2,400 from the bank. Each year, the bank charged 6% simple interest. How much interest will be owed in 1 year if no payments are made? What's with people not making payments? It's really bad if you don't make payments. They like repossess your items, like lose your house and your car. Always make your payments if you have payments. All right, so she borrowed $2,400. So that would be my P, right? P is the original amount. So she borrowed $2,400. How much the interest rate as a decimal would be what? 6% as a decimal would give me 0.06. Don't forget the extra zero in there, Chelsea. 0.06. It's okay, you're fine. Just make sure you double check it before you type it into like Desmos or something. Make sure you double check it. And how long did she not make payments? How many years did she not make payments for? 1 year. Perfect. Let's figure out how much interest she will owe. So 2,400 times 0.06 times 1. It looks like she's going to have to pay also another $144. So $144 is what she'll have to pay. And that was the last question.